All right. So, welcome everyone to our week 11 session, which is on surveying. So, we have a match today, right? So, I think that's why very less of you, or maybe no, most of you will prefer to see the recording. Yeah, but we have to do the session on time. So, yeah, let's start. So, we are going to discuss two questions for our quota, and then we'll discuss some more interesting questions. First question is going to be on closing error, and then second question also will be on closing error, but a kind of a different problem, right? So that we can develop our concepts regarding what kind of questions can be asked. Okay, now let's start. So first question is from GATE 2015, question number 35. It is, the question goes like, in a closed loop traverse of 1 kilometer total length, the closing error in departure and attitude are 0.3 meters and 0.4 meters respectively. The relative precision of this traverse will be. Okay. So what does this question telling us? The question is saying that, let's say you did surveying of a closed loop in a polygon. Well, for our simplicity, I am saying polygon. So you started at some point A, then you went to point B. For simplicity, we are going to take only 3 points for now. And then you went to point C. Then you came back to close your loop to point A. Now, due to one error or the other, due to human error or due to instrument error in measuring these angles, what can happen is these angles of forward bearing and back bearing. Due to these things, what can happen? You may not end up at the same point where you landed. Right. So in that case, there is an error. What is that error? That error is, let me zoom it just a little bit for a while, and then I will zoom out. So that error is this. That error is the vector joining these 2 points. That should be same. Now if you take component of this vector, it is going to be in horizontal and vertical direction, right? So this is given to us as 0.3, and this is given to us as 0.4 meters, right? So this error, which is actually the summation of latitudes plus summation of departures, is given to us as 0.3 square plus 0.4 square, and if you solve it, it is going to turn out to be 0.5 meters. Why this happens and why it is written like this, why the error is written like this? If you are already familiar, you can skip ahead. I am going to explain it in a most simplistic manner. So let's start with the point that is given to us. All right, so let's take this point. Let's take this traversal point. Now, starting with point A, when you go to point B, you move in vertical direction AB, right? This is your vertical one movement. So let's say this is your D1. From B to C, when you move, and consider that this A point, actually the original A point, is the origin. So this D1 is positive, and from B to C when you move, some of it is in positive, some of it is in negative. All right. Now, when you move from C to A dash, you should have moved actually to what? To A, right? So it should be D3. Now we realize that in our y-axis, if this was y-axis and this is x-axis, we moved D1, D2 and D3 and we ended up on the same line, that is x equal to 0. So the total movement in y direction should be 0. Similarly, if you will see that you moved from A to B in x-axis, then B to C in again x-axis, and then from you should have moved from C to A. So the summation of all these movements considering the sign convention should be 0. But since we did not, since we did not end up at the same point where we started, the summation is not 0. Summation is not going to be 0. Why? Due to error. And that is what we design or we signify as the error. So error horizontal is Li, error vertical is summation of the departures and attitudes. All right. And the total error or the net error, not the net error, which basically the resultant error is the sum of these two values, which we have as 0.5 meters. Now, but that is not what is asked of us. What is asked of us is relative precision. And what is that? That is the total error magnitude divided by the traversal length. What is the traversal length? Traversal length is the sum of the line AB, BC and CA. Basically, how much length you have covered in your traversal. That is nicely given to us as 1000 meters. So when you put in the values of 0.5 meters divided by 1 kilometer, that is 1000 meters, you end up with the value of 1 by 5000. That is your answer. So A is the correct answer. So I hope you understood something from this question. Okay, let's go to the next question. GATE 2011, question number 47. The observations from a closed loop traverse around an obstacle are given. Now, what is the value of the missing round off to the near missing measurement round off to near 10 mm? Okay, yes. See, here we are traversing from P to Q to R to S, P to Q to R to S, and then to T and then again to P. And this is the length of our traversal. We are given all these lengths, but one is not given to us. And we are given the azimuth of each of our traversal. So let us try to visualize what is happening. Right, so let's say we are at point P. All right, this is our point P. Then we took a clockwise angle of 33 degree and we move to Q. So this is Q, this is 33 degree, 33.75 degree. So basically in GATE you are given nice scientific calculator, so you should put actually all these values, and as you can see the options are also very close, so any kind of approximation is going to bite us in the back if we perform. And this length is L. Yeah, now from Q we move to R with an angle of 86, so it is not 90 degree, so it is also going to be something like this. So this is our R, this is theta B. All right, from R to S we move at angle 169 degrees, so this is going to be 169 degree. All right, and this length from Q to R is 300 meters. From R to S is 354.524 meters, and this is S. All right. Now from S to T, we are at 243 degrees. So this would have been 270, this whole thing. We are a little less than that. So 243 degrees. Something. We can write any value. So here I'm going to write theta C and theta D. All right. Now, this last angle, as you can see, this is what we will expect if you want to add, join the line from T to P, that it is going to be this line and this angle coming around more than 270 degrees. So something around 317 is given to us, theta E. All right. So all these lengths are 450 and 268 meters. Good. Now using this, we have to find our L. What concept we are going to use? Since we are not given the error, neither the horizontal error, nor the total error, and not the vertical error, we are going to say error is 0. What does that mean? That means that summation of the horizontal, vertical, and summation of the horizontal components of these lengths is going to be 0. That means when you started at P and you went to Q, R, S, T, and then came back to P, you came back to P only. You didn't go to any point near this. You didn't go to P dash, you came back to P only. So summation of the departure and latitude is going to be 0. Now, one thing to note here in these type of questions, that when you get these angles, don't get scared that I have to convert it into some kind of internal angles and then we have to compute. When these angles are given to you, you just use them as it is. So let's say I want to do summation of latitude is equal to 0 or departure is equal to 0. I'm going to take cos of all these angles. Okay, so it's going to be L into cos of theta A. And what is theta A? 33.75 degree plus 300 into cos of 86.3847 degree plus 354.524 into cos of 169.3819 degree plus 450 into cos of 243.9003 degree plus 268 into cos of 317.5 degree is going to be equal to 0. And when you solve this expression, you are going to get your length value to, sorry, not to, 396.785 meters, or you can say 396.79 meters. So perform these calculations carefully without any kind of approximations and you are going to get the correct answer, that is B. All right. And you can do the same thing if you just, instead of the cos, you do sine. Even if you do sine, you can get the answer. All right. So what I will suggest is you try using cos and sine both, and then you can get the answer in both the cases, just to uh, make it stick to your brain for a little bit longer. Okay, so these are the two questions that we have to do for our quota. Now let's go to a little more interesting questions. Okay, so the question goes like, a 20-meter chain was found to be 10 centimeter too long after chaining a distance of 2000 meters. It was found to be 18 centimeters too long at the end of the day's work when the total chaining distance is 4000 meters. What is the true distance if the chain was correct before the commencement of the day's work. So what this question is telling us is that in the starting of the day, the chain length was correct 20 meters. After chaining a 2000 meter distance according to the chain, that means after laying down the chain for 100 times, we found that the chain length was 20.1 meters. So it increased by 10 centimeters throughout this period. And at the end of the day, after additional 2000 meters according to the chain, or 100 times additionally laying this chain down, we realized that the chain length had again grown to 20.18 meters. All right. So if you take an average, so what is happening here exactly? The thing is, the chain length has been increasing due to heat or due to wear and tear as we are laying down the chain and measuring these distances. Okay. So what we will say is that the approximate or the average chain for these 100 times of laying down of the chain and measuring the distance was an average of these two readings. So it is 20.05 meters. And for the second half of the day, it is again the average of these two readings. That is 20.14 meters. Okay. Now, what do we know that is correct? The correct thing that will not change is we have laid down this chain 100 times in both the halves. So that means the actual measurement that we have done in the first half is 20.05 into 100, and in the second half is 20.14 into 100. So it is 2005 and 2014. So the total distance that we have measured is 4019 meters. So the correct answer for this question is B. All right. Simple question, but it may be intimidating if you are looking at this question for the first time. So I hope this clarifies whatever doubt you may have for this question. Now this is an important question. In a closed traverse ABC, so we had a closed traverse ABC. What do we have? We have the four bearings. So let's say this is A, this is B, this is C. So we have the four bearing at A and then back bearing at B, then four bearing from B and back bearing from C to B, then four bearing from C to A, sorry, from C to A and back bearing from A to C. Right, we have all this information. And they are saying that only A is free from local interaction. So whatever the readings that have been done on the A station are correct. But we cannot say the same thing for B and C. And the question is, what is the correct bearing at CB? Okay. So CB is nothing but the back bearing of this for this line BC. Okay. So we have to find out the correct value for that. Now, what should we know about forebearing and back bearing? See, the relation between forebearing and back bearing is that the difference of these two values has to be 180 degrees. So this is a forebearing if you are going from point A to B, and this is the back bearing. If you look at this carefully, you will see that this angle and this angle is same. So what we can say, back bearing minus forebearing is 180 degrees. Now this is true only if the forebearing is uh, less than 180 degrees. If the forebearing is more than 180 degrees, let's say you are going back for some reason, you are moving this way. So this becomes your forebearing, and this becomes your back bearing. In this case, forebearing minus back bearing will be 180 degrees. So just analyze the value, whichever is greater, and according to that, you have to see which one is bigger, whether the forward bearing is bigger or back bearing is bigger, and what you have to do, whether you have to do plus 180 degree or minus 180 degree to get the other value from the one given to you. All right. So since A is correct, so the forward bearing measured at A for the line AB is going to be correct. Now this is less than 180. So this means that back bearing should be 20 plus 180, that is 200 degree. But what we have measured at B, from B when we measured this back bearing, we measured 201 degree. So what is the error? Error is of plus 1 and the correction should be minus 1 degree, right? Now, this correction at B is going to be applied to all the readings that we have taken at B. So we have identified from the back bearing that should be for the line AB that the correction is minus 1 degree. Now same minus 1 degree correction is going to be applied to the forward bearing of line BC. So what you measured as 101 degree is actually minus 1 of the minus 1 degree of that, and it is forward bearing of BC is 100 degree. Now, according to our relation, if this is 100 degree, so back bearing of BC, or you can say forward bearing of CB, is actually 100 plus 180, that is 280 degrees. All right. So now we know that the value that is given to us that we have actually measured is 278. So the error is of minus 2 degrees and the correction will be plus 2 degrees. So at our station B, we had the error of minus, or the correction of minus 1 degree. However, at our station C, we have a different correction, and that is of plus 2 degrees. So the same correction will be then again applied to the forward bearing at CA. So instead of being 278, it will be again 280 degrees. So we don't need to go any further, because what we can see clearly here is that they asked us the correct bearing CB, that is we have identified is 280 degrees. So we can leave the answer here, that is D, 280 degrees, that is the correct answer. All right. Okay. All right. So this is today's last question, I think. Yeah, this is today's last question, and it's a pretty neat question actually. So it also warrants you to remember how actually the experiments are done. Okay. So the question is, the following readings were taken with a dumpy level and a 4-meter leveling staff on a continuously sloping ground at 30-meter interval. And these are the readings that are given to us: 0.68, 1.45, 1.855, 2.33, 2.885, 3.38, 1.0. The reduced level of the fourth point is given to us, and they are asking the reduced level of the first point. Okay, remember two things. So let me write. First reading is always backside at benchmark, preferably at benchmark where we know the reduced level. Second, whenever the trend of readings change, then remember that we have changed the station location. Okay, what do I mean by that? We'll see. This is a great example to explain that. Okay, so consider this is our station, And first we performed backside. So we looked back, and then we took the reading at our benchmark at point A, and this reading was 0.68. Now I think you should know at this level that this reading is nothing but this particular height, okay, from the ground. All right, and this is our station height. Then what we did, we moved our staff forward. Remember, this height is actually 4 meters. So we moved our staff forward 30 meters. We moved our staff 30 meters forward. So this is our second location. And maybe let me draw this also. So this will be our staff line. Just for reference, I'm drawing it. This is our third location. This is fourth location. This is fifth location, and something like that. And we went on and measured the distances or the height. When we measured it here, we got the value of 1.455. Here we got the value of 1.855. Here we got the value 2.338. Here it is 2.885, and one more, it is 3.380. Now see, why did I draw this line? Maybe I think you guys will be able to understand that this staff is maximum height is 4 meters only, and this 4 meter will be from the ground where you are laying it down. Now since this is a sloping down kind of ground, so after some point your station may not be able to, your station level is going to be above your staff height, so you have to change your station location. And when you do that, the last point where you took your forward reading, you have to take a back side, and that is given to us as 1.055 meters. All right. So I hope this clears some concepts or any of the doubts that you may have in this question. Now, one more question that can be asked in this type of reduced level kind of question is that tell whether or multiple select question that this continuous what is given to us is continuously sloping ground, right? Now the question can be either what is the slope of the ground, or it can be whether the ground is sloping or moving downwards, or is it or you are on a hill, or you are climbing the hill, or you are going downwards towards the hill. So since the readings are increasing, that means the staff is going actually down, as you can see from this question also. So this means you are going down the hill. All right. Okay. So what? Now let's solve the question. So what is given to us is the reduced level of the fourth point. So this is first, second, third, fourth. For this point, we are given the reduced level. That means we are given the height of this point. What is that? RL 79.100 meters. Now using this and the staff reading, we can identify the height of this station line or the line of sight. What is it? It is nothing but the reduced level of the given point plus the staff reading. It is 79.100 plus 2.338. And this staff, the eye level or the line of sight level is maintained throughout. So can we get the reduced level at A, which is the desired point? It is going to be the line of sight minus the reading, that is staff reading, that is 0.68. It will be reduced level at A. So it is 79.100 minus 0. Or plus 0 plus 2.338 minus 0.68 is equal to RLA. So what is the value of RLA? Let us see. So we have, so 2330. Oh, yeah, my fault actually. This is 2330. Yeah. Hmm. So the answer for this question is going to be 80.75 meters. So option A is correct. So we have looked at different type of questions that can be asked, with traversing in this session. And previously we saw questions with photogrammetry. So I hope you have some kind of idea and about what kind of questions can be asked. And yeah, okay. So let's hope that India wins this match, and you know, so that you can justify why did you attend the session. All right. Thank you, guys.